If a company needed to scale, it hired more engineers, expanded cloud capacity, and pushed new features. Growth was largely a function of code and capital. But in 2026, something more physical is becoming the limiting factor. Big tech's next move depends on the US power grid. That may sound dramatic, but the shift is real. Artificial intelligence has transformed electricity from a background operating cost into a strategic dependency. The future of AI deployment, cloud expansion, and digital infrastructure now hinges on how much reliable power the grid can deliver, and how fast. The first reason is simple. AI consumes enormous amounts of electricity. Training advanced models requires thousands of high-performance GPUs running continuously for weeks. Inference at global scale means data centers operating at high utilization around the clock. Power density per rack has surged compared to traditional cloud workloads. This isn't incremental growth in demand, it's exponential. Data centers that once required tens of megawatts now require hundreds. Some planned AI campuses are being designed at gigawatt scale, and electricity supply cannot be expanded overnight. The US grid was built over decades. Transmission lines, substations, and transformers require long planning cycles and regulatory approval. Interconnection queues for new large-scale power users can stretch years into the future. That creates friction. If big tech wants to deploy the next generation of AI infrastructure, it must secure energy capacity in advance. Without guaranteed power, data centers cannot operate, no matter how advanced the chips inside them are. The second issue is geographic concentration. Major data center hubs like Northern Virginia and parts of Texas are already facing grid strain. Utilities in these regions are being forced to evaluate how much new capacity they can realistically provide. Some projects have been delayed simply because sufficient power was not immediately available. This forces tech companies to rethink expansion strategy. Instead of building wherever connectivity is strong, they must prioritize locations where energy supply is scalable and reliable. Energy access is becoming a site selection criterion equal to fiber infrastructure. Another layer is energy cost volatility. As electricity demand rises, wholesale power prices can fluctuate. Long-term contracts help stabilize costs, but securing them requires negotiation and capital commitment. Companies that lock in favorable energy agreements gain cost predictability. Those that cannot may face margin pressure as AI workloads scale. In a market where investors are closely watching capital expenditure and profitability, power costs directly influence financial strategy. There is also the renewable energy dimension. Many tech giants have pledged carbon neutrality or 24/7 carbon-free energy targets. As AI increases electricity consumption, meeting those commitments becomes more challenging. Renewable energy projects take time to develop. Grid integration requires coordination. Storage solutions must scale alongside generation. If renewable deployment lags behind AI demand, companies face difficult trade-offs between sustainability targets and infrastructure growth. The grid is not just about supply, it's about balance. AI data centers require constant, stable power. Renewable sources like solar and wind are intermittent. That increases reliance on storage systems, backup generation, and advanced grid management technologies. All of these components require investment and policy alignment. Geopolitics adds another layer. Energy security is increasingly viewed as part of national competitiveness. AI capability is tied to compute capacity, and compute capacity depends on electricity. If the US grid cannot expand reliably, it could slow domestic AI deployment relative to other regions investing aggressively in energy infrastructure. In that sense, grid modernization is not just an energy issue, it is a technology competitiveness issue. There is also a regulatory component. Large-scale data center projects require local approval. Communities are scrutinizing energy usage, water consumption for cooling, and environmental impact. Utilities must balance residential and industrial demand. Policymakers must weigh economic benefits against infrastructure strain. Big tech's expansion plans are now intertwined with public infrastructure planning. AI product cycles move quickly. Infrastructure cycles move slowly. A company can design a new chip in under 2 years. Building a new transmission line can take much longer. This mismatch forces tech companies to forecast years ahead and commit capital long before revenue materializes. Strategic miscalculations become costly. Why does big tech's next move depend on the US power grid? Because AI is transitioning from a digital experiment to industrial infrastructure. The next breakthroughs in AI capability will require larger training clusters, more distributed inference nodes, and edge deployments integrated into everyday devices. All of this multiplies energy demand. Without a grid capable of supporting that growth, deployment slows. Innovation timelines extend, costs rise. In the early internet era, bandwidth was the bottleneck. Fiber expansion unlocked new platforms and services. In the AI era, electricity may be the bottleneck. Grid modernization, energy diversification, storage innovation, and regulatory coordination are becoming as important to tech growth as semiconductor design. Big tech can control chip architecture, it can design cooling systems, it can build data centers, but it cannot independently rebuild the national power grid. That requires collaboration with utilities, regulators, and policymakers. The companies that align their infrastructure strategy with grid realities will scale more smoothly. Those that ignore the constraint may face delays and rising costs. For decades, technology felt intangible, weightless, detached from physical limitation. AI has changed that. In 2026, the future of digital innovation runs through transformers, substations, and transmission lines. And that means big tech's next move doesn't just depend on software roadmaps. It depends on whether the US power grid can keep up.